Good morning, students. Today we are going to see about our laboratory experiment, micro laboratory experiment. That micro laboratory experiment having 7 experiment in our curriculum. That experiment having that is a reflex characteristics. So reflex klystron characteristics. That reflex klystron characteristics are one of the experiment of our microwave laboratory. So mode characteristics of reflex klystron. So this mode characteristics we have to characterize our reflex klystron tube. Okay, so this is our overall test bench. So this is our microwave test bench. This contains microwave power supply, then klystron tube, then isolator, then variable attenuator, then frequency meter, slot line section, then detector mount, then finally output we have to see in this CRO, as well as power you can measure in the VSWR meter. Okay, before you are going to start your experiment, first you have to set the klystron power supply initial setup. So this is our klystron power supply. This initial setup have to done by, so repeller voltage. This repeller voltage finally fully closed, maximum value. Then beam voltage have to set in the minimum value. So FM modulation and AM modulation have to set in the middle of the position. So the display is having in the off position, then voltage, current, then repeller voltage, as well as our function numbers AM, then FM, continuous wave, then external. Okay, so finally you have to set this initial setup. You can switch on your power supply. So first you have to switch on your main supply, then second you have to switch on your microwave klystron power supply. So this microwave klystron power supply, you have to set the function knob in the AM position. Okay, so AM position, you have to wait minimum 2 minutes for warm up time. So warm up time, this klystron tube take it as current as usual 1 or 2 milliamps. Okay, this is now your klystron tube take it as current. So finally you can adjust beam voltage up to 14 to 16 milliamps. So now I adjust beam voltage into 12 voltage. Okay, 12 voltage. So next we have to see the output of our klystron mode characteristics in the CRO. Okay, so this klystron tube generate the microwave waveform, then isolator. This isolator used to travel the waveform in the only one direction, that is forward direction. Then this is a unidirectional device. So reverse direction maximum attenuation will be done in this isolator. Then variable attenuator, you can adjust the waveform into the variable attenuator. So that is close the attenuate our waveform, or open release the waveform. Then frequency meter, you can calculate the frequency directly. So which our microwave frequency is traveled through this frequency meter. So these are all ports are connected in the rectangular waveguides. So after that frequency meter, this is slot line section. This slot line section used to measure the indirect frequency calculation. So okay, this calculation slot line section having vernier scale and also ordinary scale. So finally detector mount. So this detector mount detect our output waveform of microwave frequency. So first you can adjust the repeller voltage from your klystron power supply. So in this experiment only the function of selected in the FM mode. So frequency modulation, FM mode. So repeller voltage I can just already we have adjusted or set in the repeller voltage into the maximum position. So this maximum position having 290 or 300 voltage. So from this voltage you can reduce our repeller voltage by taking the different mode characteristics of reflex klystron. First adjust our repeller voltage into the different voltage. So if you are reducing your repeller voltage, you can see the output waveform of different mode characteristics in your CRO. So this is one of the mode. So you can decrease the repellor voltage. We are taking different mode characteristics. So this is one of the way. Another decreasing your repellor voltage, you will get another different mode. So next another different mode. So first you are taking this tabulation. So different we are getting three different mode characteristics. Then respect our power measured from the VSWR meter. Okay, so mode characteristics, model characteristics is graph is, so this is frequency versus repellor voltage, then power versus repellor voltage. Okay, so finally you are taking three different sets of mode characteristics: output voltage versus power, as well as output voltage versus frequency. So graph is drawn by the three different mode characteristics. Okay, so repellor voltage, similarly frequency, then repellor voltage, similarly then power. So how can you measure the microwave power into your meter is VSWR meter is. So this is your characteristics, mode characteristics, one of the mode characteristics. This probe can be removed. The same probe will be inserted into VSWR meter. So this is your output power. Suppose if your reflection is more means, you can adjust the range in dB level. Okay. So this is high range. So you have to reduce 40. So now your power is dB level is, that is 20. So normal dB or expanded dB, which you can flexible, that is which you can want, that you can select. Power is adjusted by coarse knob and fine tune knob. Okay. So this is 2 dB. So this output waveform power dB is 2 dB. So the power also mentioned in this table, and also repellor voltage as well as frequency. So finally you will get this different three modes characteristics of reflex klystron. That's all about our experiment of mode characteristics of reflex klystron, our microwave laboratory experiment. Thank you. Thank you, students.